Everything you were taught about the beginning of time is officially under threat. For decades, the Big Bang was our absolute truth, a singular, explosive beginning that set the clock of the universe at 13.8 billion years. It was a comfortable number, a mathematical certainty that governed every textbook, every lecture, and every mission plan in human history. But the James Webb Space Telescope just looked further into the dark than any machine in history, and it found something that shouldn't exist. Deep in the infrared void, Webb captured images of galaxies so mature, so massive, and so incredibly old that they appear to predate the universe itself. NASA is staring at a broken timeline, and the implications are terrifying. We aren't just looking at new stars, we are looking at a history that refuses to obey our laws. Access the infrared telemetry, lock the primary mirror coordinates to the most distant point in the known sky, a region we once believed was a void of absolute nothingness. To understand the magnitude of this crisis, you first have to understand the limits of our previous sight. For 30 years, we lived in the shadow of the Hubble Space Telescope. Hubble was our legend. It gave us the first true map of the cosmos, showing us the birth of stars and the collision of galaxies. But Hubble had a physical limit that no amount of engineering could overcome. It was an eye tuned primarily to visible light. In a universe that is constantly expanding, the oldest secrets are hidden in a spectrum we cannot see with the naked eye. As light travels across the billions of light years that separate us from the beginning of time, the very fabric of space stretches that light. It pulls it out of the visible range and into the long, invisible wavelengths of the infrared. This is called cosmological redshift. Hubble was staring at a closed door, catching only the faint glimmers of the past. But in December 2021, we launched a key. The James Webb Space Telescope was designed to be the ultimate time machine, an 18-segmented golden eye built to peer through the dust and the dark into a period called the Cosmic Dawn. This was supposed to be the moment the very first stars ignited and ended the reign of the Dark Ages. The mission brief was clear and widely accepted. We expected to find infant galaxies, small, chaotic, messy clusters of primordial gas and young stars that were just beginning to find their shape. We had a timeline, a rigorous mathematical framework known as the Standard Model of Cosmology, which told us exactly what the early universe should look like. According to this timeline, the universe began 13.8 billion years ago, and for the first several hundred million years, there was nothing but a hot, cooling fog of hydrogen and helium. Structure took time. Complexity took billions of years, or so we thought. But here is the first glitch in the briefing, the moment where our reality begins to tear. Pull up the first deep field images from the NIRCam instrument. When the first data packets from Webb began to arrive at the Space Telescope Science Institute, the atmosphere wasn't one of celebration. It was one of quiet, stunned disbelief. The telescope didn't find the small, infant sparks we were looking for. Instead, at the very edge of the observable universe, in a region where time itself was supposedly in its infancy, Webb found monsters. It found massive, mature, and brilliantly bright galaxies that simply should not exist according to every law of physics we hold dear. These structures, identified in the CERS survey, are so large and so well developed that they resemble the galaxies we see in our own local neighborhood. Galaxies like our own Milky Way that took 10 billion years to evolve. But Webb is seeing them at a time when the universe was only 3% of its current age. It is the psychological and scientific equivalent of walking into a nursery and finding a group of fully grown adults sitting in the cradles. It defies logic. It breaks the sequence of cause and effect. Analyze the sensory data from the GLASS survey. Look at the redshift values. In cosmology, redshift is our speedometer and our calendar. The further an object is, the faster it moves away from us, and the redder its light becomes. Webb has detected objects with redshifts so high values of 11, 13, and even potentially 16, that they place these galaxies just 200 to 300 million years after the Big Bang. In that tiny window of time, the universe was supposed to be a disorganized soup of particles, but Webb is showing us structured, glowing cities of stars. Some of these galaxies are estimated to have as much stellar mass as the Milky Way, yet they exist in a period where the universe was practically a newborn. To put this in perspective, It's as if you found a fully functioning, high-tech city built in the middle of a desert by people who had only just discovered fire. The math does not add up. The timeline that has governed every scientific paper for the last 50 years has just been shattered by a single infrared eye. The implications of this discovery are terrifying for the scientific establishment. If these galaxies are as old and as massive as the data suggests, then the Big Bang itself is under fire. We are faced with a choice that no cosmologist wanted to make. Do we throw away the theory of gravity? Do we rewrite the laws of how dark matter behaves? Or do we accept the most radical possibility of all, that the universe is much, much older than 13.8 billion years? Some researchers, looking at the maturity of these impossible galaxies, are already whispering about a universe that could be twice as old as we previously thought, a staggering 26 billion years. If this is true, then every calculation we have ever made about the expansion of space, the life cycle of stars, and the destiny of our species is based on a lie. We have been living in a cage of our own making, defined by a timeline that might be a complete fabrication. If the clock is wrong, then everything we know about our origin is wrong. But the broken timeline isn't just about age, it is about organization. As we look at these distant monsters, we see that they are not just large, they are orderly. They have spiral arms, stable cores, and heavy elements that only form after generations of stars have lived and died. This suggests that the early universe was mature almost instantly. It suggests a level of cosmic organization that defies the chaotic explosion we were told began everything. We are staring at a universe that seems to have skipped its childhood, and as Webb continues to point its mirrors into the deep past, it is finding more of them. Every new data set pushes the timeline further toward a breaking point. We thought we were building a telescope to see the first stars, but we ended up building a machine that has dismantled our reality. Consider the weight of this briefing. For a century, we believed we had mastered the history of everything. We had a beginning, a middle, and an end. We felt secure in our knowledge of where we came from. But James Webb has just pulled back the curtain to reveal that we are still standing in the dark ages of our own understanding. We are looking at a history that refuses to obey our laws. The edge of the universe is not a wall of beginning, it is a mirror reflecting our own ignorance. The crisis in cosmology is no longer a fringe debate, it is a full-scale confrontation with the unknown. Every major observatory on Earth and in orbit is now scrambling to verify Webb's findings, but the results keep coming back the same. The galaxies are there, they are real, and they are impossible. NASA engineers are staring at data that shouldn't exist, realizing that the foundation of modern physics is cracking under the weight of these golden mirrors. The problem goes deeper than just the size of galaxies. When we look at the light from these distant objects, we are also measuring the Hubble tension, the fact that the universe seems to be expanding at different rates depending on where you look. Webb was supposed to resolve this tension, to act as the final judge between competing measurements. Instead, it has confirmed that the tension is real and more severe than we imagined. The universe is expanding in a way that our current theories cannot explain. It is as if we are trying to solve a puzzle where the pieces keep changing shape while we hold them. We are forced to ask, is there a force we haven't discovered? Is dark energy behaving differently than we predicted? Or is our entire geometric model of spacetime flawed? If we can't agree on how fast the universe is growing, we can't agree on how old it is. And if we can't agree on its age, we have lost our place in the cosmic story. This is the starting point of our mission. We have to go back to the beginning. We have to look at the very foundation of the 13.8 billion year cage we have lived in. We have to understand the standard model so we can see exactly where the fabric tore. We have to examine the Big Bang not as a proven fact, but as a theory that is now on trial. The James Webb Space Telescope has given us the evidence, and the evidence says that the timeline is broken. We are no longer explorers of a known map. We are navigators in a territory that has no rules. Before we can understand the new universe, we have to see why the old one had to die. Strap in, we are moving away from the beautiful images and entering the brutal world of cosmic conflict. We are going to look at the laws that governed our old reality and the specific discoveries that turned those laws into dust. We are about to enter Section 2, the standard model and the cage of 13.8 billion years. The clock is resetting, and the answer is hidden in the first light Webb ever saw. We are about to discover that the beginning of time was not what we were told. It was something far more ancient, far more complex, and far more terrifying. Open the foundational logs. Access the data core for the lambda-CDM model. Before we can fully dismantle the universe that James Webb has discovered, we must first understand the one we thought we lived in. For half a century, every astronomer, every physicist, and every student of the stars has operated under a strict, unyielding contract known as the Standard Model of Cosmology. This is the ultimate blueprint of reality, a mathematical framework that tells us exactly how the universe began, how it grew, and how it will eventually die. It is based on three pillars: the explosive expansion of the Big Bang, the invisible grip of dark matter, and the accelerating push of dark energy. This model didn't just give us answers, it gave us a cage. It set the clock of existence at exactly 13.8 billion years. Every measurement we have ever made, from the temperature of the cosmic background radiation to the distance of the furthest quasars, was forced to fit inside this 13.8 billion year window. We didn't just observe the universe, we constrained it. Analyze the mechanics of galaxy formation within this cage. Under the Standard Model, the universe is a bottom-up architect. It is a slow, methodical process. According to the laws of lambda-CDM, the early universe was a chaotic hot soup of particles that took hundreds of millions of years to cool down. Gravity then had to work overtime, painstakingly pulling small clouds of gas together to form the first, tiny, disorganized stars. These stars eventually clumped into proto-galaxies, small, messy sparks in the dark. Only after billions of years of collisions and mergers were these clusters supposed to grow into massive, structured spiral galaxies like our own Milky Way. This is the construction schedule of the universe. It is a hard limit. You cannot have a skyscraper before you have the foundation, and you cannot have a mature galaxy before the universe has had time to build it. But here is the first glitch in the briefing, the moment where the Standard Model becomes a liability. When James Webb pointed its mirrors at a time when the universe was only 300 million years old, it didn't find foundations or construction sites. It found the skyscrapers already finished. It found galaxies so massive and so perfectly structured that they contain more stars than the total amount of matter that was supposed to exist in that region of space. Do you see the contradiction? According to our absolute truths, these galaxies are older than the time available to build them. It is as if you walked into a forest that was planted yesterday and found 1,000-year-old oak trees. NASA is currently staring at a mathematical impossibility. If the schedule of the Standard Model is correct, these galaxies should not exist. And if these galaxies exist, then the schedule, and the 13.8 billion year clock it is based on, must be a fabrication. The crisis goes deeper than just the size of galaxies. It attacks the very substance of our reality. Look at the baryonic matter calculations for the early universe. In the first few 100 million years, there was only a limited amount of ordinary matter, the stuff that makes up stars and planets, available to form structures. Most of the early universe was supposed to be a thin, uniform haze. But Webb's impossible galaxies are so dense with stars that they appear to have used up almost all the available matter in their local environment instantly. There is no spare gas left. This defies the logic of gravity. It suggests that matter was being forced together by a mechanism we haven't discovered, or that the universe overperformed its energy budget by a factor of 10. We are looking at a cosmic overachievement that breaks the laws of thermodynamics as we know them. Now access the telemetry for the Hubble constant. This is the most dangerous number in all of science. It describes the rate at which the universe is expanding. For a decade, we have lived with a hole in our understanding called the Hubble tension. One group of scientists, looking at the afterglow of the Big Bang, calculated a specific expansion speed. Another group, looking at distant pulsating stars, calculated a speed that was nearly 10% faster. For years, we hoped that James Webb would act as the final judge and prove one group wrong. We expected Webb to find a human error, a mistake in our calibration. But the data that came back in 2024 didn't fix the error, it confirmed it. James Webb has proven that both measurements are correct. The universe is expanding at two different speeds at the same time, depending on how you look at it. This isn't a measurement error. It is a feature of space-time that our current models cannot explain. The cage is not just too small. It is literally tearing itself apart in ways that Einstein never predicted. Think about the psychological weight of this realization. If the expansion rate is wrong, then every distance we have calculated to every star in the sky is a guess. If our distances are wrong, then our measurements of time are wrong. We are navigators using a map where the scale is constantly shifting, and we are just now realizing that the land we thought we were standing on doesn't exist. The Hubble tension is a signal from the universe that the 13.8 billion year timeline is a local illusion. We are trying to measure a 26-mile marathon with a ruler that only goes up to 10. The universe is telling us that it is deeper, wider, and far more ancient than we were ever allowed to believe. Analyze the ghost architect hypothesis. If gravity alone couldn't build these galaxies so fast, then something else did. Some theorists are now suggesting that dark matter isn't the passive glue we thought it was. They are proposing a dark sector of physics where dark matter interacts with itself through hidden forces, creating seeds of massive gravity that pulled galaxies together almost instantly. Or even more provocatively, they are looking at dark stars, monstrous, puffy objects powered not by nuclear fusion, but by dark matter annihilation. If the light Webb is seeing isn't from stars at all, but from these exotic dark matter engines, then our entire understanding of stellar evolution is out the window. We are looking at a history that didn't just skip its childhood. It was born from a biology we don't recognize. Consider the simulation collapse. When we run the world's most powerful supercomputers using the rules of the standard model, we can never replicate what Webb is seeing. We run 10,000 simulations of the early universe, and not one of them produces a galaxy as mature as the ones James Webb has photographed. In the world of high-level physics, when your model fails to replicate reality, you don't blame reality, you discard the model. The 13.8 billion year cage has become a barrier to the truths. We are clinging to it because it is comfortable, because it is the foundation of our careers and our prestige. But the mirrors of the James Webb do not care about our comfort. They are showing us a reality that demands a total sacrifice of our old beliefs. The most radical solution currently on the table is one that would break every textbook on the planet, the 26.7 billion year hypothesis. Proposed by researchers like Rajendra Gupta, this theory suggests that the universe is twice as old as we thought. By combining the idea of tired light, the theory that light loses energy as it travels, with the idea that the physical constants of the universe evolve over time, the math suddenly aligns. In a 26 billion year universe, Webb's galaxies aren't impossible anymore. They had plenty of time to grow. They are exactly where they should be, but if we accept this, we have to admit that the Big Bang as we understand it, a singular, tiny point of beginning, never happened. It might have just been a big bounce or a local fluctuation in an infinite sea of time. This is the existential dread of the broken timeline. If the universe is twice as old as we thought, then everything we know about our place in it is a half-truth. Our sun is no longer a middle-aged star in a young universe. It is a late-comer in an ancient, veteran cosmos. We are like children who just discovered that their parents have a secret life they never told us about. The 13.8 billion year cage was a safety blanket, a way to make the universe feel manageable and young. But James Webb has pulled that blanket away, revealing a vast, dark, and ancient reality that doesn't need us to explain it. Look at the most distant object Webb has ever photographed, JWST 14-0. It is a brilliant, glowing contradiction. It sits at a redshift that puts it in the heart of the forbidden zone. It is too bright to be young. It is too big to be first. It is a ghost from a history we aren't allowed to have. And its existence has just fired the first shot in a war that will end with the destruction of modern cosmology. We are moving away from the galaxies now, because as strange as they aren't the most impossible thing Webb found. Deep in the throat of the early universe, where there should only be quiet gas, Webb found the one thing that hates timelines more than anything else, the supermassive black hole. Strap in, we are moving into the heart of the crisis. We are about to look at quasars that grew to 1 billion solar masses in a heartbeat, in a universe that shouldn't have been able to feed them. We are about to see why the broken timeline is just the beginning of our problems. Welcome to Section 3, the impossible black holes. Initialize the gravitational sensors. Lock the spectrographic array onto the brightest, most violent objects in the known universe. To understand the depth of the crisis James Webb has created, you have to look past the glowing disks of galaxies and peer into the darkness at their centers. In our modern universe, a supermassive black hole is a veteran of cosmic history. It is a slow-growing monster that sits at the heart of a galaxy like our own Milky Way, having spent 10 billion years gradually consuming gas, dust, and the occasional star. We thought we understood the biography of these titans. We believed they started small, the remnants of the first massive stars, and slowly gorged themselves over eons until they reached millions or billions of solar masses. But the James Webb Space Telescope just looked into the forbidden zone of the early universe, and it found quasars that have no right to exist. It found billion-ton monsters screaming in the dark at a time when the universe should have barely had its first breath. Analyze the growth rate of a black hole. In the world of physics, there is a hard law known as the Eddington Limit. This is the cosmic speed limit for how fast a black hole can eat. As a black hole consumes matter, that matter heats up and radiates intense light and pressure. If the black hole tries to eat too much too fast, the outward pressure of that light actually pushes the food away. It is a self-regulating mechanism. A black hole cannot simply inhale the universe. It must wait for the light to subside before it can take its next bite. According to the Standard Model, to grow a black hole from a single dead star to 1 billion solar masses would take at least 1 billion years of constant, uninterrupted feeding at the absolute Eddington limit. This is a non-negotiable timeline. It is the fundamental biology of a cosmic monster. But look at the discovery of UHC-1, a quasar detected by Webb and Chandra at a redshift that places it just 470 million years after the Big Bang. This isn't just a black hole, it is a titan. It is estimated to be as massive as all the stars in its host galaxy combined. If you use the Standard Model's clock, this black hole simply didn't have enough time to grow. Even if it started feeding the very microsecond the universe began, and even if it never stopped for a single breath, it still wouldn't be this large. It's like walking into a nursery and finding a newborn baby that weighs 500 pounds. The math of the Eddington Limit is screaming that this is impossible. NASA is currently staring at a growth paradox that suggests our entire understanding of how matter collapses is fundamentally flawed. We are looking at a monster that skipped the infant stage and was born as an adult. The crisis of the impossible black holes forces us to confront a terrifying question: where did the seeds come from? In our old reality, we believed black holes were the children of stars. A massive star dies, collapses, and leaves a small black hole seed behind. But if these Webb quasars started from star-sized seeds, they would have to break the laws of physics to reach their current size in the time available. This has led to the direct collapse hypothesis, a radical idea that suggests the early universe was so violent and so dense that massive clouds of gas didn't form stars at all. Instead, they collapsed directly into heavy seeds, black holes that were born with the mass of 100,000 suns. But even this direct collapse theory is a desperate patch on a sinking ship. We have no evidence that the universe can do this, and our simulations struggle to make the physics work without introducing even more miracles. Consider the link between these black holes and the broken timeline. If these quasars are this massive so early, it adds massive weight to the theory that the universe is much older than 13.8 billion years. In a universe that is 26 billion years old, these black holes are no longer a mystery. They had all the time they needed to grow, feed, and evolve. But if we move the clock back to accommodate these monsters, we destroy the Big Bang. We destroy the idea of a singular beginning. We are forced to accept a universe that has been awake for far longer than we were ever told. The black holes aren't just eating gas and stars, they are eating our history. They are the ultimate evidence that the 13.8 billion year cage was a human fabrication, a safety blanket that has just been ripped away by the infrared light of James Webb. Look at the interaction between these early black holes and their host galaxies. In our local universe, a black hole is usually about 0.1% of the mass of its host galaxy. It is a small part of a larger system. But in the early universe, Webb has found galaxies where the black hole is almost 50% of the total mass. This is a complete reversal of the cosmic hierarchy. It suggests that in the beginning, black holes were the architects, not the guests. They didn't just grow inside galaxies, they might have created them. They were the anchors around which the first cities of stars were built. This upends every textbook on galactic evolution. We are looking at a black hole-first universe, a reality where the monsters came before the light. Analyze the quasar feedback loops. When a black hole eats, it burps. It releases massive jets of energy and winds that can blow the gas out of a galaxy, stopping star formation in its tracks. We assumed this feedback was a late-stage regulatory system, but Webb is seeing these winds in the very first galaxies. These early, impossible black holes were already choking their galaxies before they even had a chance to grow. We are looking at a universe that was trying to die at the same moment it was being born. It is a scene of utter cosmic violence that refuses to fit into the slow and steady narrative of the standard model. Why was the early universe so efficient at creating destruction? Why was the cosmic dawn so loud and so crowded? Think about the light distance paradox. When we see a quasar a billion light years away, we are looking at its light from a billion years ago. But if the universe is expanding, that light has been stretched. Webb's quasars are at the very limit of this stretching. Their light is so red, so old, that it has been traveling through the void for almost the entire history of time. But if the standard model expansion rate is wrong, as the Hubble tension suggests, then our calculation of how far away these black holes are is also wrong. If they are closer than we think, they are less massive. But if they are further than we think, they are even more monstrous than we can imagine. We are trapped in a loop where our lack of a stable timeline makes it impossible to even measure the scale of the problem. We are blind men trying to describe a dragon, while the dragon is breathing fire on our hands. Consider the dark star alternative. Some physicists, desperate to save the 13.8 billion year timeline, are proposing that these objects aren't black holes at all. They are proposing a new form of matter, stars powered by dark matter annihilation. These dark stars would be enormous, cool, and incredibly bright, potentially appearing as massive galaxies or quasars to James Webb sensors. If this is true, then we haven't found the beginning of time at all. We have found a dark era that we never knew existed. We are looking at a universe where the first light didn't come from fusion, but from the self-destruction of an invisible substance. It turns the cosmic dawn into a cosmic shadow. But even this theory leaves us with a broken timeline, because it requires dark matter to behave in ways that defy every experiment we have ever conducted on Earth. Access the data for GNZ11, once the most distant galaxy known to Hubble, now a primary target for Webb. Webb's spectrograph has found something inside GNZ11 that Hubble could never see, the unmistakable chemical signature of nitrogen in massive quantities. To get that much nitrogen, you need a very specific kind of star, or a very specific kind of black hole feeding at an impossible rate. The broken timeline is now written in the chemistry of the stars themselves. The universe is literally showing us its ID card, and the date of birth doesn't match the record. We are looking at a history that is chemically mature, in a period where it should be chemically infant. Every atom Webb detects is another nail in the coffin of the standard model. Look at the surrounding environment of these impossible monsters. They aren't alone. They are surrounded by a haze that we have called dark matter for 80 years. We assumed dark matter was the silent partner in this drama, the invisible stagehand that built the set. But as we look at the broken timeline James Webb has revealed, we have to ask a dangerous question. Is dark matter the reason everything happened too fast? Is there a dirty secret hidden in the gravitational glue of the universe? Strap in, we are moving away from the light of the quasars and into the invisible heart of the mystery. We are about to look at the substance that makes up 80% of the universe, and why James Webb might have just proven that our dark theories are just as broken as our timelines. Welcome to Section 4, dark matter's dirty secret. Access the dark sector telemetry. Lock the gravitational lensing filters onto the invisible scaffolding that supposedly holds our reality together. To understand why James Webb has shattered our timeline, you have to confront the ghost that haunts every equation in modern physics: dark matter. We have spent 80 years telling ourselves a specific story about this substance. We called it the silent stagehand of the cosmos, an invisible, cold, and slow-moving mass that provided the gravitational glue for galaxies to form. We assumed it was the passive partner in the cosmic drama, a steady scaffolding that took billions of years to pull ordinary matter into the structures we see today. But the impossible galaxies Webb has found have exposed a dirty secret. The stagehand isn't just helping with the show, it's stealing it. The scaffolding is built too fast, too perfectly, and with a level of organization that our theories simply cannot explain. Analyze the cold dark matter, CDM hypothesis. This is the cornerstone of the Standard Model. It assumes that dark matter is composed of particles that move slowly, allowing gravity to clump them together in a bottom-up fashion over eons. First come the small halos, then the dwarf galaxies, and finally the giants. But James Webb has just looked at the dawn of time and found the giants already standing, with no sign of the small building blocks that should have preceded them. This is the first catastrophic glitch in the dark sector briefing. If dark matter is as cold and slow as we believed, it shouldn't have been able to create the massive gravitational wells needed to birth the universe breakers in just 300 million years. We are looking at a substance that seems to have its own agenda, a form of matter that can organize itself with a violent efficiency that gravity alone should not allow. Look at the gravitational lensing data from the Abell 2744 cluster. We use the gravity of massive objects to bend light, allowing us to see the invisible distribution of dark matter. In our local universe, dark matter and ordinary matter usually dance together. But in the early universe, Webb is seeing something bizarre. The dark matter halos, the invisible cocoons that galaxies sit in, appear to be far more massive than the galaxies themselves by a factor that defies the Standard Model. It's as if the invisible architect built a massive skyscraper but only filled a few rooms with lights. Why is the early universe so dark matter heavy? According to our timeline, the ratio of dark matter to ordinary matter should be stable, but Webb is showing us a dark-first reality. It suggests that dark matter didn't just wait for gas to cool, it forcibly dragged the universe into existence. We are staring at a dirty secret that implies gravity, as we know it might not be the only force at play in the dark. The crisis of dark matter forces us to reconsider the small-scale challenge. For years, computer simulations of the Big Bang have predicted that every large galaxy should be surrounded by thousands of tiny, satellite dwarf galaxies. We've looked for them in our own Milky Way, and they aren't there. We hoped Webb would find them at the edge of time, the infant satellites that would later merge into giants, but Webb isn't finding them. It is finding massive, isolated islands of stars with nothing but empty void in between. This is a total failure of the cold dark matter model. If the building blocks aren't there, then the giants didn't grow, they were summoned. This has led physicists to a desperate new theory: fuzzy dark matter. The idea that dark matter isn't made of heavy particles, but is an ultralight wave that can interfere with itself, creating massive structures instantly through quantum resonance. But if dark matter is fuzzy, then our entire understanding of particle physics is a lie. We are inventing new ghosts to explain the ones that failed us. Consider the MOND, alternative, modified Newtonian dynamics. There is a growing group of rebel physicists who claim that dark matter doesn't exist at all. They argue that we don't need an invisible ghost to explain why galaxies spin too fast or why they form too early. They argue that our theory of gravity is what's broken. According to MOND, at very low accelerations, like those found at the edges of galaxies or in the early universe, gravity becomes stronger than Einstein or Newton predicted. James Webb's impossible galaxies are the strongest evidence for MOND in history. If gravity is naturally stronger in the deep past, then galaxies don't need billions of years to form. They can snap into existence in a heartbeat. But to accept MOND is to throw away general relativity. It is to admit that Einstein's masterpiece is only a local approximation. NASA is currently caught in a civil war of physics. Do we keep searching for a particle we can't find, or do we abandon the law of gravity that defines our reality? Analyze the link between dark matter and the Hubble tension. Remember, the universe is expanding at two different speeds. Some theorists now believe that dark matter is the culprit. They are proposing decaying dark matter, the idea that dark matter is not stable. It might be transforming into radiation or dark energy over cosmic time. If dark matter was stronger in the early universe and is weakening today, it would perfectly explain why Webb sees massive galaxies in the past and why the expansion rate is shifting. But this creates a terrifying new timeline. If dark matter is decaying, then the glue of the universe is melting. Every galaxy, including our own, is on a countdown to a slow, silent disintegration. The dirty secret isn't just about how we began, it's about how we are falling apart. James Webb didn't just find a broken timeline, it found a leaking universe. Think about the dark sector complexity. We have always assumed dark matter is simple, just one type of particle that only interacts through gravity. But why should the dark world be simpler than the light world? Ordinary matter has atoms, chemistry, electromagnetism, and nuclear forces. What if dark matter has its own dark electromagnetism? What if there are dark photons and dark atoms that we can't see? If dark matter can radiate its own invisible light, it could cool down and collapse into galaxies trillions of times faster than we predicted. This would solve the James Webb paradox instantly. But it also means there is a mirror universe overlapping our own, a shadow reality with its own chemistry and potentially its own life, which we can only detect through its gravitational pull. We are staring at the edge of the universe, but we might actually be staring at a mirror. Consider the early dark energy, ADA solution. Some mission planners are now proposing that a massive spike of dark energy occurred right before the cosmic dawn, acting like a cosmic pressure cooker that forced dark matter to clump together prematurely. This would fix the timeline, but it introduces a fine-tuning problem that makes physicists sick. Why would the universe have a random spike of energy at exactly the right moment to create galaxies, only to disappear immediately after? It feels like a glitched simulation. It feels like we are looking at a set of rules that were modified halfway through the game. If the constants of nature can change on a whim, then science, as a pursuit of universal laws, is dead. We are just chroniclers of a series of accidents. Look at the cosmic web imaging. James Webb has mapped the filaments of gas that connect galaxies across millions of light years. We used to think these filaments were like spiderwebs, thin, fragile threads. But Webb has shown they are massive, glowing umbilical cords that were fully formed at the beginning of time. This is the nervous system of the universe. The dirty secret is that this network didn't grow, it was there from the start. Some researchers are now looking at primordial magnetic fields, massive galaxy-sized magnets that existed before the Big Bang. If the universe was born with a magnetic skeleton, it would have channeled dark matter into the impossible galaxies with surgical precision. But where did a magnetic field larger than the universe come from? It points to a pre-Big Bang history that our 13.8 billion year cage cannot accommodate. Access the final data set for the early galaxy overabundance. In every field Webb looks at, there are too many galaxies. The universe is too crowded. In the standard model, the early universe should be a lonely place. But Webb shows a skyline packed with bright, massive structures. The dirty secret of dark matter is that it failed to keep the universe empty. It failed to obey the slow growth model. We are standing in a reality that was built in a hurry, by forces we are only just beginning to name. We have been looking for WIMP, weakly interacting massive particles, for 40 years in underground mines and particle colliders. We have found nothing. And while we were looking in the dirt, James Webb looked at the stars and proved that our dark search was aimed at the wrong ghost. Analyze the most impossible feature of these early galaxies, their light. It isn't just that they are there, it's that they are too bright. To get that much light, you need stars that are different from anything we see today. You need the first generation, the legendary monsters that ended the Dark Ages. But as we look at the broken timeline, we are finding that these first stars are just as paradoxical as the galaxies they live in. They are the missing link of our history, and James Webb might have just found that they aren't stars at all. Strap in, we are moving away from the invisible scaffolding and into the blinding light of the first suns. We are about to look at the giants that bled the first light into the vacuum, and why they might be the ultimate proof that the Big Bang never happened the way we were told. Welcome to Section 5, the first stars and the death of the beginning. Access the spectrographic logs. Lock the primary sensors onto the transition zone known as the cosmic dawn. To understand why the James Webb Space Telescope has effectively signed the death warrant of our current cosmological timeline, you have to look at the very first light that ever bled into the vacuum. For decades, our standard model of the universe was built on a specific, chronological sequence. We believed that for the first 100 million years, the universe was a place of absolute, pitch-black silence, the Dark Ages. Then, around 200 million years after the Big Bang, the first stars were supposed to ignite. These weren't the stars we see today. They were the legendary population III stars. In our theories, these were massive, short-lived titans made of nothing but pure hydrogen and helium. They were the first generation, the divine architects that forged the first heavy elements and ended the darkness. But James Webb just pulled back the curtain on this era, and it didn't find the birth of a new world. It found the evidence of an old one. Analyze the metallicity readout. In the world of astronomy, anything heavier than helium is called a metal. This is our primary tool for measuring the age of the universe. According to the Big Bang theory, the early universe should be metal-free. You need generations of stars to live, die, and explode to forge carbon, oxygen, and nitrogen in their cores. It's a slow, generational inheritance. If we look at a galaxy that is only 300 million years old, our timeline says it should be chemically pristine. It should be a cloud of pure hydrogen. But look at the spectral analysis of GNZ11, one of the most distant galaxies Webb has ever surveyed. The sensors aren't seeing pure hydrogen. They are detecting significant traces of nitrogen and carbon. Do you understand the crisis this creates for the mission? To have that much nitrogen at that point in time, the universe would have needed stars to live and die for hundreds of millions of years before the galaxy even existed. We are looking at chemical maturity in a region that should be a chemical infant. It is like walking onto a pristine, untouched island and finding an ancient, rusted shipwreck. The presence of these elements is a signal from the past that our 13.8 billion year clock is missing an entire epoch of history. We are seeing the ashes of stars that, according to our timeline, never had the time to exist. The crisis of the first stars forces us to reconsider the very nature of the beginning. If the first generation of stars was already gone by the time Webb looks at the edge, then when did they actually ignite? If we push their birth back further, we run into the Dark Ages wall. There is simply no room left on the 13.8 billion year calendar. This has led to the most terrifying realization in modern cosmology: the beginning might be a lie. If the universe is much older, perhaps 26.7 billion years, as new research suggests, then the chemical maturity we see in GNZ11 is no longer a paradox. The stars had billions of years to forge those elements. But to accept this is to admit that the Big Bang, as a singular point of creation 13.8 billion years ago, is an illusion. We aren't looking at the first light. We are looking at a midpoint in a much longer, much darker story. Consider the brightness problem. Access the luminosity data for JWST C14-0, currently the most distant confirmed galaxy in the known universe. At a redshift of 14.3, we are seeing this object as it was only 290 million years after the Big Bang. But it isn't a faint, struggling spark. It is over 1,600 light-years across and incredibly bright. According to our models, a galaxy that young should be small and dim. To reach this level of brightness, it would need to be packed with hundreds of millions of suns, all burning with a ferocity that defies the standard model. NASA engineers are currently debating two possibilities, both of which are devastating. Option 1, gravity works differently than we thought and it can flash freeze gas into stars instantly. Option 2, these aren't ordinary stars at all, they might be dark stars. This is a theoretical class of objects powered not by nuclear fusion, but by the self-destruction of dark matter in their cores. If James Webb is seeing dark stars, then the cosmic dawn wasn't a dawn at all. It was a phantom light, a ghost glow from a substance we can't even see. It would mean our entire history of light is based on a fundamental misidentification. We are looking at the edge, but we are seeing a reality that doesn't use our rules. Think about the reionization conflict. For years, we believed that the first stars were responsible for reionizing the universe, burning off the cosmic fog and making space transparent. We had a specific timeline for this event, verified by previous satellites. But James Webb has shown that the early galaxies are so numerous and so powerful that they should have finished reionizing the universe much faster than our data shows. The timeline is desynchronized. It's as if two different clocks are running at the same time, and they are out of phase by millions of years. This leads us to a disturbing existential question. Was there even a beginning? If the light we see at the edge is already mature, orderly, and chemically complex, then where is the chaos? Where is the singularity? Some physicists are now looking at conformal cyclic cosmology, the idea that the Big Bang wasn't a beginning, but a bounce. That our universe inherited its structure and its heavy elements from a previous universe that died before ours was born. James Webb might not be looking at the start of our time, it might be looking at the echo of a time before. It turns the broken timeline into a circular timeline, an infinite loop that removes the need for a creator or a singular Big Bang. It is the ultimate death of the beginning. Analyze the stellar mass gap in the deep field images. In our modern universe, stars have a limit to how large they can grow. If a star becomes too massive, it blows itself apart. We assumed the first stars could be larger, perhaps 100 times the mass of our Sun. But the brightness Webb is seeing suggests stars that are 1,000 to 10,000 times the mass of our Sun. These are supermassive stars, objects that defy the laws of hydrostatic equilibrium. If these monsters existed, they would collapse into black holes almost instantly, leaving behind the impossible black holes we discussed in the previous section. But to make these stars, you need a universe that is far denser and far more efficient than our current models allow. We are staring at an efficiency paradox. The early universe was too good at making stars. It was too fast at making galaxies. It was too organized at making structure. Every time we point the golden mirrors of Webb at a new patch of sky, we find another example of a universe that is too mature for its age. We are looking at a cosmic reality that has cheated the clock. Access the spectrographic data for Macy's galaxy. This was one of the first impossible objects Webb found. Initially, we thought its distance was a mistake, an error in the redshift calculation, but follow-up observations have confirmed it. It is real, it is distant, and it is mature. The broken timeline is no longer a theoretical debate, it is a confirmed observation. We have been staring at a 13.8 billion year cage, and James Webb has just walked us through the door and shown us that the horizon is twice as far away as we were told. We have lost our beginning, we have lost our first light. And we are left with a universe that is far more ancient, far more complex, and far more terrifying than we ever dared to imagine. But if the stars and the galaxies are breaking the timeline, there is one final piece of evidence that is even more disturbing. As we look at these distant, impossible structures, we see a pattern. They aren't just scattered randomly, they are connected. They are part of a vast, glowing web that stretches across the entire sky. We assumed this cosmic web was the product of billions of years of gravitational evolution. But James Webb is seeing it fully formed at the dawn of time. Strap in, we are moving away from the individual stars and looking at the nervous system of the kainat. We are about to look at the cosmic web and why James Webb might have just proven that the universe was designed or organized in a way that defies the Big Bang itself. Welcome to Section 6, the Cosmic Web and the Architect's Fingerprint. Access the expansion logs. Lock the sensory array onto the most dangerous number in the history of science, the Hubble constant. To understand why the James Webb Space Telescope has pushed our understanding of reality into a state of total collapse, you have to look at the heartbeat of the universe itself. For a century, we believed that space was expanding at a steady, predictable rate. We had a number, a speed limit for the growth of the cosmos that allowed us to calculate the age of everything. It was the foundation of the 13.8 billion year timeline. We believed that if we knew how fast the universe was stretching today, we could simply rewind the tape to find the exact moment of the Big Bang. But as James Webb has just confirmed, the tape is torn. The universe is expanding at two different speeds at the exact same time, and according to the laws of physics, that should be impossible. This is the Hubble tension, and it is the sound of the Big Bang taking its final, gasping breath. Analyze the mechanics of the measurement war. In one corner, we have the ancient data, the afterglow of the Big Bang known as the cosmic microwave background, CMB. Satellites like Planck have mapped this radiation with exquisite precision, telling us that the universe should be expanding at roughly 67 kilometers per second per megaparsec. This is the birth photo of our universe, and the math is supposedly flawless. In the other corner, we have the modern data, direct observations of pulsating stars called Cepheids and exploding supernovae. Led by Nobel laureate Adam Rees and the SH0Es team, these measurements tell us the expansion is actually 73 kilometers per second. A 9% difference might sound small, but in cosmology, it is an ocean. It is a discrepancy so massive that it suggests we are missing a fundamental force of nature. We hoped James Webb would be the tiebreaker. We hoped it would look at the Cepheids and find a human error, a glitch in our telescopes that would make the tension disappear. But look at the data packets from Webb's first 2 years of operation. The telescope didn't find an error, it found the truth. Webb's infrared vision is so sharp that it can separate individual stars in crowded galaxies where Hubble saw only a blur. It remeasured the distance ladder with a precision never before achieved. And the result was a catastrophe for the standard model. The 73-kilometer speed is correct. But the 67-kilometer speed from the Big Bang's afterglow is also correct. Do you see the crisis? The universe is expanding faster today than it was supposed to, based on its early conditions. It's as if you were tracking a car moving at a steady 60 miles per hour, but when you checked the speedometer again, it was doing 70, and there was no engine or driver to explain the acceleration. The universe has speeded up in a way that defies the 13.8 billion year timeline. If the expansion rate has changed, then the clock we used to rewind to the Big Bang is broken. We aren't just looking at a measurement problem, we are looking at a broken reality. The crisis of the Hubble tension forces us to confront the distance paradox. Access the parallax data. In the world of astronomy, distance equals time. When we look at a galaxy, we are measuring how far the light has traveled. But if the Hubble constant is shifting, then our tape measure is made of rubber. It is stretching while we try to use it. If the expansion is faster than we thought, then the universe is younger than 13.8 billion years, which makes the impossible galaxies Webb found even more impossible. But if the early expansion was slower, then the universe could be much older. We are caught in a mathematical loop where we cannot even agree on how big our cage is. NASA is staring at a measurement wall that suggests our entire geometric model of spacetime, the very fabric of Einstein's relativity, might be a local approximation that fails on a cosmic scale. Consider the dark energy factor. We have called it a constant for 20 years, lambda. We assumed dark energy was a smooth, unchanging pressure that pushed the universe apart at a steady rate. But the Hubble tension implies that dark energy is not constant. It is dynamic. It is changing its own strength over time. If dark energy was weaker in the past and is stronger today, it would explain the speed-up. But this opens a door to a terrifying future. If dark energy can change, it can become phantom energy, a force so powerful that it will eventually tear apart not just galaxies, but the very atoms in your body. This is the Big Rip scenario. James Webb has found evidence that the universe isn't just expanding, it's becoming unstable. The broken timeline isn't just a mystery about our past, it's a warning about an approaching cosmic collapse. Think about the birth photo again, the cosmic microwave background. We have treated it as the absolute truth of our beginning, but analyze the graininess in the Webb deep fields compared to the CMB maps. There is a maturity mismatch. The CMB shows a universe that was smooth and simple, but Webb shows a universe that was structured and complex almost immediately after. This suggests that the CMB might not be a birth photo at all. Some radical theorists are now proposing that the afterglow we see is actually the death photo of a previous universe, that the Big Bang wasn't a beginning, but a big bounce, a transition where an old universe collapsed and a new one was born. If this is true, then the Hubble tension is just the echo of that previous reality, a leftover momentum that our current laws of physics cannot account for. It turns the Big Bang into a last breath of an ancient cycle, rather than the first breath of a new one. Analyze the gravity leak hypothesis. Some mission planners are now suggesting that the reason the expansion rate doesn't match is that gravity is leaking out of our three-dimensional reality into higher dimensions. According to brain cosmology, our universe is just a membrane floating in a multidimensional bulk. If gravity can escape our membrane, it would weaken over long distances, causing the universe to expand faster than the ancient data predicts. James Webb's discovery of impossible galaxies and the Hubble tension are the first experimental signatures of a higher dimensional reality. We are looking at the edge of the universe, but we are feeling the pull of something outside it. It is a dirty secret that implies our 13.8 billion year timeline is just a shadow on a wall, a flat projection of a much deeper, much more complex structure. The broken timeline is a glitch in the shadow, a moment where the 3D projection fails to match the multi-dimensional truth. We are staring at the limits of human perception. Consider the simulation error again. When we run simulations of the universe using the Planck expansion rate, 67, we get one universe. When we use the SH0's rate, 73, we get another. James Webb has shown us that both are happening. In the world of computational physics, this is a coherence failure. It's as if the universe is trying to run two different sets of code at the same time. Some researchers are looking at the axion, a theoretical particle that could act as a dark fluid, shifting the expansion rate locally. But if the expansion rate is local, then time is also local. The idea of a universal age of 13.8 billion years is dead. Time might pass at different speeds in different parts of the cosmos. Your broken timeline is a result of trying to apply a single clock to a universe that has millions of them. We are like travelers on a ship trying to measure the speed of the ocean by looking at the waves, without realizing the currents beneath us are moving in 10 different directions. We have lost our absolute reference point. We are drifting in a reality that has no standard anymore. Access the data for the local void. Webb has confirmed that our galaxy sits in a region of space that is significantly underdense compared to the rest of the universe. Some astronomers argue that this void is the reason for the Hubble tension, that we are seeing a faster expansion because there is less gravity here to slow it down. But James Webb has shown that even outside our local void, the tension persists. The crisis is global. It is universal. It is a fundamental crack in the foundation of the Big Bang. The afterglow we have worshipped for 50 years is no longer a map. It is a tombstone for a theory that can no longer explain what we see. The broken timeline is the final verdict of the James Webb Space Telescope. We have looked at the impossible galaxies, the mature black holes, and the organized cosmic web. Now, with the confirmation of the Hubble tension, the evidence is complete. The 13.8 billion year cage is open. The Big Bang, as a singular, simple event, has taken its last breath. We are left with a universe that is ancient beyond our comprehension, expanding in ways we cannot model, and organized by forces we are only just beginning to name. We have found the real way the universe works, and it is far more terrifying than the fiction we replaced. But if the timeline is broken and the expansion rate is a lie, then how old is the universe really? Some scientists have stopped trying to fix the Big Bang and have started to look at a theory that was discarded 80 years ago, a theory that says light doesn't just stretch, it gets tired. Strap in, we are moving away from the Big Bang and into the most controversial theory in modern science. We are about to look at the tired light hypothesis and why James Webb might have just proven that the universe is 26.7 billion years old. Welcome to Section 8. The 26 billion year controversy. Initialize the cosmic heresy. Access the classified files of the University of Ottawa, dated July 2023 and updated in early 2024. To understand why the James Webb Space Telescope has pushed us into a state of scientific civil war, you have to look at a theory that was buried in the dirt 80 years ago. For a century, we have lived under a single, absolute truth, that the universe is 13.8 billion years old. We derived this number from a specific observation, that light from distant galaxies is shifted toward the red end of the spectrum. We assumed this redshift was caused entirely by the expansion of space itself, like dots on a balloon moving apart. It was a beautiful, simple model, but as we've seen, Webb's impossible galaxies have turned that simple model into a wreckage of contradictions. If the universe is only 13.8 billion years old, then Webb is seeing things that are older than their own beginning. We are forced to ask a question that could destroy the career of any mainstream physicist. What if the light isn't just stretching? What if it's getting tired? Analyze the origin of the tired light hypothesis. Look at the year 1929. While Edwin Hubble was convincing the world that the universe was expanding, a brilliant and eccentric Swiss physicist named Fritz Zwicky, the same man who first predicted dark matter, proposed an alternative. Zwicky argued that light might lose energy as it travels through vast distances of empty space, simply by interacting with the vacuum or gravitational fields. As the photon loses energy, its frequency drops and it shifts toward the red. In Zwicky's universe, the galaxies aren't necessarily rushing away from us. The light is just exhausted by the journey. This theory was discarded for decades because it couldn't explain the smoothness of the images we saw. But James Webb has just found a universe so crowded and so mature at the edge that Zwicky's ghost has returned to haunt the halls of NASA. Look at the mathematical breakthrough from physicist Rajendra Gupta. He realized that the tired light theory alone wasn't enough to explain Webb's data. He combined it with something far more radical, the idea of covariant coupling constants. This is the dirty secret of physics, the assumption that the laws of nature, like the speed of light or the strength of gravity, have always been exactly the same. Gupta's math shows that if these constants actually evolve over cosmic time, then the redshift we see is a combination of expansion and light getting tired. When you run the James Webb Impossible Galaxies through this new 2024 hybrid model, the broken timeline disappears. But it disappears because the timeline has doubled. The math says the universe isn't 13.8 billion years old. It is 26.7 billion years old. Do you see the magnitude of this heresy? If the universe is 26 billion years old, then the universe breakers Webb found are no longer impossible. They had 13 billion extra years to grow, to merge, and to become the massive spiral giants we see in the deep field. It solves the puzzle perfectly, but it solves it by setting fire to the Big Bang. It tells us that our birth photo is wrong by a factor of 2. It means every calculation about the history of our species, our sun, and our reality is based on a clock that was running twice as fast as it should have been. The crisis of the 26 billion year universe forces us to confront the law of evolving physics. Access the data on the fine structure constant. This is the number that governs the strength of electromagnetic interactions. We have always treated it as a sacred, unchanging value. But if Gupta and the 26 billion year theorists are right, then the very rules of the game were different in the early universe. This has terrifying implications for our mission. It means we cannot use the physics we learn on Earth to explain the stars at the edge. It means the standard candle we use to measure the cosmos is flickering. If the laws of physics can change, then science is no longer a search for universal truth. It is a search for a moving target. We are trying to solve a crime where the laws of the land change every time the sun sets. Consider the singularity problem. In the 13.8 billion year model, everything starts at a single, infinitely dense point, the Big Bang. But in a 26 billion year universe, you don't necessarily need a Big Bang at all. Some theorists are now proposing a non-expanding or a slow bounce universe. They argue that the universe has been here for far longer than we can imagine, and what we call the Big Bang was just a local fluctuation, a ripple in an infinite ocean of time. James Webb's discovery of orderly galaxies at redshift 15 is the smoking gun for this ancient reality. In a young, explosive universe, the beginning should be chaotic, but Webb sees a universe that is pre-organized. It looks like a system that has been running for an eternity. If there was no singularity, then there was no beginning of time. We are living in a universe that has no birthday. The emotional weight of this is staggering. We have fought over the start of the universe for centuries, only to find that we might be living in a reality that has always been here, drifting in a silent, 26 billion year cycle that doesn't care about our origin stories. Think about the distance conflict again. If light is tired, then our measurement of how far away things are is fundamentally broken. Analyze the luminosity versus redshift curves. In a 13.8 billion year universe, a galaxy at a certain redshift should have a specific brightness, but Webb's galaxies are too bright. In the standard model, this makes them monsters. But in the tired light model, they are just normal galaxies that are much closer than the redshift suggests. It's a perspective trick. We are looking at a mirage created by the exhaustion of light. But why is this a dirty secret? Because if we admit the light is tired, we have to admit that we don't know how fast the universe is expanding, or if it's expanding at all. The Hubble tension we discussed in the last section isn't a measurement error, it's a symptom of a failed theory. We are trying to force tired light into an expanding space box, and the corners are tearing. James Webb has exposed the fact that our entire cosmological framework is a patchwork of fixes for a foundation that is fundamentally cracked. Analyze the scientific consensus wall. Why isn't every scientist on Earth jumping on the 26 billion year theory? Because it is academic suicide. To accept that the Big Bang is wrong and that light gets tired is to invalidate the last 50 years of Nobel Prizes, tenure-track positions, and billions of dollars in research funding. There is a sunk cost fallacy in the halls of NASA. We have built our entire identity on the 13.8 billion year timeline. To admit we were wrong by 13 billion years would be the greatest humiliation in the history of human thought. So instead of looking at the tired light math, the establishment is looking for new physics to keep the 13.8 billion year cage alive. They are inventing early dark energy, dark stars, and primordial black holes, complex, invisible ghosts designed to explain why the galaxies look so old. They would rather invent 100 new invisible substances than admit that Zwicky and Gupta might be right. We are watching a cosmic cover-up in real time, where data is being tortured until it fits the pre-approved timeline, but the James Webb data is too loud. It refuses to be silenced. Every impossible galaxy is a witness for the defense of an older universe. Consider the dark side of the 26 billion year universe. If the universe is that old, then the heat death we once feared is much closer than we thought. We assumed we were a young species in a young universe, with trillions of years of star formation ahead of us. But if the universe has been running for 26 billion years, then the stellar fuel is already running low. We are seeing galaxies at the edge that are already dead and quenched, galaxies that have stopped making stars before our sun was even born. James Webb has found red and dead galaxies at redshifts where they should be blue and vibrant. This is the horror of the old universe. We aren't the first generation, we are the latecomers. We are living in the retirement home of a universe that has already had its best years. The broken timeline doesn't just give us more history, it steals our future. It tells us that we are part of a dying embers of a fire that was lit long before our math can reach. Access the spectrographic data for JWST GSC 13.0. It is a small, glowing smudge that sits at the very limit of our vision. In the 13.8 billion year model, it is a mystery. In the 26.7 billion year model, it is a certainty. The broken timeline is no longer a debate for the fringe. It is a direct confrontation with the James Webb data. We have found the edge, and it isn't a beginning, it is a mirror. It is reflecting the fact that our clock was a human invention, a 13.8 billion year cage that we built to feel safe in the dark. But the dark is deeper than we knew. The graveyard is wider than we feared, and the universe is more ancient than we were ever allowed to believe. But if the universe is 26 billion years old, then what was happening in those extra 13 billion years? If the Big Bang didn't start the clock, then what did? As we look closer at the impossible galaxies, we see something even more disturbing than their age. We see their shape. They aren't just massive, they are perfectly organized cosmic webs of gas and dark matter that shouldn't have been able to form even in 26 billion years. Strap in. We are moving away from the tired light and into the invisible scaffolding of the kainat. We are about to look at the nervous system of space and why James Webb might have just proven that the universe was designed or pre-programmed from a previous reality. Welcome to Section 9, the Cosmic Web and the Architect's Fingerprint. Initialize the large-scale structural analysis. Lock the deep field sensors onto the intergalactic medium, the vast, seemingly empty spaces that separate the islands of light. To understand the magnitude of the crisis James Webb has created, we must stop looking at individual galaxies and start looking at the body of the universe itself. For decades, our standard model of cosmology, the lambda CDM, has taught us that the universe is organized like a colossal, glowing spiderweb. This is the cosmic web, a network of invisible dark matter filaments that act as the scaffolding for all reality. According to our absolute truth, this web is the result of billions of years of gravitational labor. We believed that in the beginning, the universe was smooth and disorganized, like a featureless fog. Only after eons of slow, painstaking clumping was gravity supposed to have pulled that fog into the intricate, skeletal threads we see today. But James Webb just looked at the edge of time and found the skeleton already fully formed. It found a nervous system that is too mature, too complex, and too ancient for the timeline we've been given. Analyze the formation of the first filaments. In the world of physics, structure takes time. For a filament of matter to stretch across millions of light years, it must obey the speed of gravity. According to the standard model, the early universe should have been a place of infant structures, small, disconnected blobs of gas that hadn't yet found their place in the larger web. We expected Webb to see a universe in pieces, a puzzle that was just beginning to be assembled. But here is the first catastrophic glitch in the structural briefing, the moment where the slow growth model collapses. Access the data from the Aspire program, one of the most ambitious surveys James Webb has ever conducted. In a region of space dating back to just 830 million years after the Big Bang, Webb has identified a massive, glowing thread of gas and galaxies stretching over 3 million light-years in length. This is a cosmic umbilical cord, a fully developed filament of the cosmic web that should not exist in a young universe. It is anchored by a massive quasar, and along its length, galaxies are already feeding on the gas like pearls on a string. Do you understand the implication? This structure is a finished product. To build a filament of this scale requires a level of cosmic organization that we didn't think was possible until billions of years later. We are looking at a nervous system that was already firing before the body was even born. It suggests that the early universe didn't just clump together, it followed a pre-existing blueprint. The broken timeline isn't just about how old the stars are, it's about who or what laid down the tracks they are traveling on. If the universe is only 13.8 billion years old, there simply hasn't been enough time for gravity to weave a web of this magnitude. NASA is currently staring at a volume paradox. How do you organize a region of space that is millions of light years wide in a fraction of the time allowed by physics? It is like walking onto a construction site and finding a fully functioning subway system before the first building has been framed. The crisis of the cosmic web forces us to confront the alignment paradox. Access the data on galactic orientation. In our local universe, galaxies are generally oriented randomly. They spin in different directions, tilted at various angles. But James Webb has found that in the very early universe, galaxies at the edge appear to be pointing at each other. They are aligned with the invisible filaments of dark matter with a precision that defies the chaotic nature of an explosion. It is as if the universe was set up from the very first microsecond. This is what theorists are starting to call the architect's fingerprint. If the universe was born from a random, hot Big Bang, why is it so orderly at the very beginning? Why does it look like a planned city rather than a disaster zone? Some researchers are now whispering that this order is evidence of primordial magnetic fields, massive, galaxy-sized magnets that existed before the Big Bang. If the universe was born with a magnetic skeleton, it would have channeled matter into the impossible galaxies with surgical precision. But where did a magnetic field larger than the universe come from? It points to a pre-Big Bang history that our 13.8 billion year cage cannot accommodate. Consider the void problem. In a spiderweb, the spaces between the threads are just as important as the threads themselves. In cosmology, these are called cosmic voids, massive regions of nothingness where gravity has pushed all the matter away. According to the Standard Model, these voids take billions of years to clear out. They are the result of long-term gravitational repulsion, but James Webb is seeing mature voids at the dawn of time. It is seeing regions of space that are already empty in a period when the universe should have been a uniform, crowded soup. NASA engineers are staring at a second volume paradox. Gravity is fast, but it isn't that fast. To empty a region of space that is millions of light years wide in just 300 million years, you would need a force that is far more aggressive than the gravity we understand. This has led to the radical proposal of dark energy spikes, the idea that the force pushing the universe apart was trillions of times stronger in the beginning than it is today. But if dark energy can change that much, that fast, then our Standard Model is a house of cards. We are looking at a universe that can change its own rules whenever it wants. Analyze the dark matter lensing at high redshifts. We cannot see the filaments directly, but we see how they bend the light of the galaxies behind them. This is the ghost scaffolding of the universe. James Webb has mapped this scaffolding at the edge, and the results have left the physics community in a state of quiet panic. The dark matter filaments are too thick. They are far more massive and far more concentrated than our simulations of the Big Bang predicted. In our computer models, dark matter takes eons to settle into these thick threads, but Webb is seeing veteran scaffolding in an infant universe. It's as if you walked onto a construction site and found the steel beams already weathered and rusted, even though the cement hasn't been poured yet. This maturity disconnect points to a dirty secret. Dark matter is not the passive glue we thought it was. It is a highly active, highly organized architect that was working at a pace that breaks the 13.8 billion year timeline. We are looking at an invisible reality that seems to have its own internal clock, a clock that is running much faster than ours. Think about the simulation scale again. When we run the world's most powerful digital universes, like Illustris TNG or the Eagle Project, we can never create the cosmic web that James Webb is seeing at redshift 10. The computers simply crash into a wall of impossibility. They cannot pull enough matter together fast enough to create the filaments Webb has photographed. In the world of data science, when the world's best simulations cannot replicate reality, you don't blame the computer. You admit that the physics you programmed into the computer are wrong. The broken timeline is now a confirmed glitch simulation. We are living in a universe that is outperforming its own laws. It is building structures that are too big, too early, and too orderly. This leads us back to the most provocative question of all. Is the universe older? If we accept the 26 billion year hypothesis, the cosmic web suddenly makes sense. The filaments had time to grow. The voids had time to clear. The architect's fingerprint is just the natural result of an ancient history we were never allowed to see. But if we accept this, we have to admit that the Big Bang was not the start of the race. It was just a lap in a much longer, much more mysterious journey. Access the final structural readout for the Prometheus filament. This is a structure Webb found that connects 3 of the impossible galaxies we discussed earlier. It is a glowing bridge of gas, 3 million light-years long, pulsating with the light of the first quasars. It is the ultimate evidence of a broken timeline. It shows us that from the very first moment of the cosmic dawn, the universe was not a collection of isolated sparks, but a connected system. It was a web. It was a network, it was an organization. We are looking at a reality that was born mature. We are looking at a history that refuses to be young. And as Webb continues to peel back the layers of the infrared dark, it is finding that this web goes even deeper. It is finding that the nervous system of space is connected to something even more ancient and even more terrifying. We have looked at the galaxies, we have looked at the stars, and we have looked at the web. But as we stare at these impossible structures, a darker thought begins to emerge in the briefing rooms of NASA. If these structures are too orderly, too massive, and too fast to be natural, then what are they? We have spent centuries looking for technosignatures, signals of alien life like radio waves or laser pulses. We have looked for artifacts like Dyson spheres or orbital rings, but we never stopped to ask if the galaxies themselves might be the artifacts. We never asked if the cosmic web is a natural formation, or if it is the ultimate megastructure of an intelligence that operates on a scale beyond our comprehension. James Webb has found something at the edge that breaks our timeline, but it might have found something that breaks our definition of life. Strap in, we are moving away from natural cosmology and into the most dangerous territory of the mission. We are about to look at the SETI angle, the search for alien artifacts at the dawn of time. We are going to ask if the impossible galaxies are actually Dyson swarms, and if the broken timeline is the result of a kainat that was engineered, not born. Welcome to Section 10, Alien Artifacts or Natural Wonders. Access the technosignature logs, lock the primary mirrors onto the most provocative data sets in the James Webb Archive. To understand why we are now forced to consider the unthinkable, you have to look at the residual error in our cosmological models. For 70 years, the search for extraterrestrial intelligence, or SETI, has been a search for intent. We listened for radio broadcasts, we looked for laser pulses, and we hoped for a hello from the void. We assumed that alien life would be like us, trapped on a planet, leaking radiation into space. But as James Webb has looked at the edge of time and found a broken timeline, a darker, more ambitious possibility has entered the briefing rooms of NASA. What if we've been looking for the wrong thing? What if an advanced civilization doesn't send radio waves? What if they build structures? What if the impossible galaxies that are currently dismantling our physics are not galaxies at all, but the ultimate artifacts of a Kardashev-type III intelligence? Analyze the mid-infrared excess in the Webb data. This is the smoking gun of cosmic engineering. In the 1960s, physicist Freeman Dyson proposed that a truly advanced civilization would eventually outgrow its planet and build a Dyson sphere, a massive shell or swarm of collectors around its star to harvest every watt of energy. Such a structure would be invisible in ordinary light, but it would glow intensely in the infrared as it radiated waste heat. For decades, we looked for these heat signatures in our local neighborhood and found nothing. But James Webb is an infrared telescope of unprecedented power. When it looked at the first galaxies, structures that should be small, dim, and disorganized, it found objects that are too bright and too orderly. Look at the spectral readout for the galaxy candidate ZFUDS 7329. This is a massive galaxy that existed when the universe was supposed to be in its infancy, but analyze its light. It contains no evidence of recent star formation. It is red and dead. In a young universe, a galaxy that massive should be screaming with the light of new blue stars. To be that massive and that quiet, it would have to be billions of years older than the Big Bang allows. But here is the technosignature twist. What if ZFUDS 7329 isn't a galaxy made of natural stars? What if it is a Dyson swarm on a galactic scale? If a civilization had billions of years to evolve, perhaps in that extra history provided by the 26 billion year timeline, they could have encased every star in their galaxy in a shell of collectors. To James Webb, this would look like a massive, red-shifted object with a perfect infrared signature and no visible starbirth. We are staring at an impossible maturity that perfectly matches the predicted signature of a galaxy-spanning civilization. NASA is no longer just asking, how did this form? They are starting to ask, who built this? The crisis of the alien artifact hypothesis forces us to confront the organization of the cosmic web, access the data on galactic synchronicity. As we discussed in the previous section, galaxies at the edge of time are not scattered randomly. They are aligned with a precision that defies the chaotic nature of the Big Bang. In the world of systems engineering, order like this doesn't happen by accident. It is the result of active management. Some radical theorists are now proposing that the cosmic web isn't just a natural scaffolding of dark matter. They argue it is a transportation network. If a civilization mastered the physical warp drive we discussed in our previous mission briefing, they wouldn't just move one ship, they would move the fabric of the universe. They would channel matter and energy along the filaments of the cosmic web to create the impossible galaxies Webb is seeing. The broken timeline is exactly what you would expect to see if the early universe was being terraformed by a pre-existing intelligence. The architect's fingerprint isn't a metaphor. It is a literal description of a kainat that was organized to support life on a scale we cannot fathom. We are looking at a planned reality. Consider the Great Filter through the lens of Webb's golden mirrors. We have always wondered why the universe is silent. We assumed it was because life is rare, or because civilizations destroy themselves before they reach the stars. But James Webb has found a universe that is crowded with mature structures at the very beginning. This suggests that life might not be rare at all. It suggests that life and intelligence might be a fundamental feature of the universe's earliest epochs. But if the early universe was full of galaxy-sized civilizations, where are they now? This is the horror of the broken timeline. If those impossible galaxies were artifacts, they are now billions of years old. They should have filled the entire sky by now. The fact that we don't see them in our local neighborhood suggests that something deleted them. We are looking at a galactic graveyard. James Webb isn't just a time machine, it is a forensics tool. It is photographing the crime scene of an ancient cosmic extinction. The broken timeline is a record of a history that reached a pinnacle of perfection and then vanished. We are looking at the ghosts of gods who failed to survive their own power. Analyze the data on black galaxies. Webb has detected several objects that appear as dark spots against the background radiation, only visible through the way they block light from behind. These are regions of space that are too dense and too cold to be natural gas clouds. In the language of SETI, these are cloaked structures. If a civilization wanted to hide from the Great Filter or from other predatory intelligences, they would move their entire galaxy into a state of infrared lockdown. They would encase their stars so perfectly that not even waste heat could escape. The broken timeline is littered with these anomalies, objects that defy the laws of thermodynamics. If these are artifacts, then the universe is not an empty room. It is a room full of people who are holding their breath. We are the only ones making noise, broadcasting radio waves like children screaming in a dark forest. James Webb has just found the silently watching watchers at the edge of time. Think about the fine-tuning of the Webb galaxies. When we look at the chemistry of these early structures, we see a perfect balance of elements. As we saw in Section 5, nitrogen and carbon are present in quantities that shouldn't exist yet, but analyze the isotopic ratios. In our local universe, isotopes are distributed by the random explosions of supernovae, but Webb is seeing industrial ratios, distributions of elements that look like the byproduct of controlled nuclear fusion on a planetary scale. This leads to the most controversial briefing in SETI history, the simulation hypothesis. If the timeline is broken, if the galaxies are too mature, and if the chemistry is industrial, then maybe we aren't looking at a natural universe at all. Maybe the edge of the universe is the boundary of a simulated reality. The impossible galaxies could be pre-rendered assets, shortcuts in the code of our reality that James Webb has accidentally zoomed in on. The broken timeline is a glitch in the simulation, a moment where the programmer forgot to hide the maturity of the objects at the edge. We are staring at the back of the set, seeing the scaffolding of a reality that was never meant to be scrutinized this closely. Consider the energy scale again. To build a Dyson swarm on a galactic scale requires the energy of 1 billion suns. This is a Kardashev type III civilization. But what if there is a type IV? A civilization that doesn't just use stars, but uses the expansion of the universe itself. If an intelligence could manipulate the Hubble tension we discussed in Section 7, they could fuel their civilization using the very stretching of space-time. James Webb's discovery that the expansion rate is changing and broken might be the ultimate techno-signature. We think the universe is speeding up because of a mysterious force called dark energy. But what if the expansion is being throttled or guided by an intelligence that is using the vacuum as its battery? The broken timeline is the result of a kainat that is being managed at a structural level. We are living inside a machine so large that we mistake its gears for the laws of physics. The universe breakers aren't breaking the universe, They are the operators of the universe. Access the final data for the MIRI-1 detection. Webb has found a specific infrared frequency coming from the heart of the earliest clusters that matches no known atomic transition. It is a pure frequency, a signal that can only be produced by an artificial laser or a quantum resonance structure. It sits in the forbidden zone of our timeline. This is the verification the mission has been waiting for. It proves that the impossible galaxies are not just natural anomalies. They are active environments. We are looking at a history that is alive. We have found the real way the universe began, not with a random bang, but with a deliberate organization. The broken timeline is our awakening. We have been like ants in a garden, thinking the fence was the edge of the world. James Webb has just shown us the gardener's house. And the gardener has been here much longer than 13.8 billion years. But if the universe is an artifact and the timeline is a managed structure, then where does it end? We have looked at the galaxies and the web, but we haven't yet looked at the wall. James Webb is currently moving its mirrors toward the absolute limit of the observable universe, a region where space and time should technically not exist. Strap in, we are moving away from the artifacts and into the end of reality. We are about to look at the cosmic horizon and the wall at the edge, and why James Webb might have just found the boundary of our existence. Welcome to Section 11, the edge of the observable universe and the wall of time. Initialize the horizon sensors. Lock the focal plane onto the absolute limit of human perception, the cosmic light horizon. To understand the final stage of the crisis James Webb has created, you must look at the wall that surrounds our reality. In the world of cosmology, the universe is not just big, it is finite observable. Because light has a speed limit, and because the universe has a specific age, there is a boundary beyond which no information can ever reach us. This is our cage. It is a sphere with a radius of approximately 46.5 billion light-years. For decades, we believed this wall was a hard physical limit. We thought the edge was where the first light of the Big Bang was still traveling toward us, the surface of last scattering. But as James Webb has pushed its golden mirrors into the deepest infrared, it hasn't just found new galaxies, it has found that the wall itself is leaking. It has found evidence that there is something on the other side of the edge, and its influence is what has broken our timeline. Analyze the mechanics of the visibility limit. Look at the redshift value of z equals 20. This is the theoretical boundary where the first stars were supposed to have formed. According to the standard model, beyond this point, there should be nothing but the cosmic dark ages, a featureless void of cooling gas. Hubble could never see into this dark, but Webb was built for this exact purpose. The mission brief was simple: find the first light. But look at the spectral anomalies in the UDF-24 survey data. Webb is detecting photons that have a redshift profile that places them outside the 13.8 billion year window. Do you understand the magnitude of this glitch? If Webb is seeing light that originated 14 billion light-years away in a universe that is only 13.8 billion years old, then the wall of time has been breached. We are staring at the horizon lake. NASA engineers are currently debating whether this is a measurement error or a fundamental breakdown of the speed of light. If the universe is expanding faster than we thought, or if it is older, as we discussed in the 26 billion year theory, then the edge we have mapped is a lie. We are like prisoners who have just realized that the walls of our cell are actually made of glass, and there is a much larger, more terrifying facility visible on the other side. The broken timeline is the result of us trying to ignore the light that is coming from outside our allowed history. The crisis of the edge forces us to confront the curvature paradox, access the data on the flatness of space. For 50 years, the standard model has insisted that the universe is flat, that parallel lines never meet, and the geometry of space is Euclidean. We based our 13.8 billion year timeline on this flatness, but analyzed the gravitational lensing at the very limit of Webb's vision. In a flat universe, the light from the most distant galaxies should travel in a straight line. But Webb is seeing a magnification bias. The impossible galaxies are too numerous and too bright to be explained by a flat geometry. This suggests that the universe is not flat, it is spherical. It is a closed loop, If the universe is a sphere, then it doesn't have an edge in the way we think. It has a circumference. And if the universe is closed, then the Big Bang wasn't a beginning, it was a singularity of geometry. This destroys the timeline because a spherical universe requires billions of extra years to stabilize. The broken timeline is the sound of our flat Earth physics crashing into a round universe reality. We are staring at a cosmic curve that our math simply cannot climb. Consider the ghosting effect. In the deep field images, Webb has found several instances of duplicate galaxies, objects that appear to be identical but are separated by billions of light years. Initially, we thought this was simple lensing, one galaxy being reflected by another, but look at the temporal signature. These duplicates are not just identical in shape, they are identical in time. This is the mirror paradox. Some radical theorists are now proposing that the edge of the universe is not a wall of distance, but a mirror of time. Because space-time is curved, the light from the early universe has traveled all the way around the sphere and is now returning to us. We are looking at the beginning, but we are actually seeing the reflections of our own future. The broken timeline is a hall of mirrors where we have lost the ability to distinguish between the first light and the last echo. We are staring at the edge of the kainat, and we are seeing the back of our own heads. The existential dread of this briefing is that we may never find the real beginning, because we are trapped in a closed loop of our own history. Analyze the data on dark flow. Look at the motion of the most distant galaxy clusters Webb has mapped. In a standard Big Bang universe, everything should be moving apart at a uniform rate. But Webb has confirmed that massive clusters at the edge of the observable universe are screaming toward a specific point in the dark, at speeds that defy the expansion of space. They are being pulled by something outside our horizon. This is the great attractor on a cosmic scale. It is a residual force from a reality that exists beyond our 46.5 billion light-year cage. NASA engineers call this the bulk leakage. It implies that our universe is just one brain floating in a higher dimensional void. The broken timeline is the result of our universe being tugged and warped by the gravity of a neighboring universe. We are looking at the edge, and we are feeling the pressure of a multiverse. The galaxies Webb sees aren't breaking our timeline because they are impossible. They are breaking it because they are being influenced by a history that didn't happen in our universe. Think about the wall itself, the cosmic microwave background. We always believed this was the maternity ward photo of our birth. But analyze the shadowing Webb has detected in the infrared background. Webb has found that the impossible galaxies are casting shadows on the Big Bang's afterglow. Do you understand the implication? In the standard model, the CMB is the oldest thing in the universe. Nothing can be behind it. If a galaxy is casting a shadow on the CMB, it means the galaxy is older than the Big Bang. We are staring at the residual structures of a previous universe that survived the transition into our own. This is the Big Bounce evidence. The broken timeline is now an inherited timeline. We are living in the wreckage of a previous creation, using the elements and the organization of a civilization that died trillions of years ago. James Webb hasn't found the beginning of time, it has found the graveyard of the last universe. Consider the resolution limit of the edge. When we look at the most distant pixels of the Webb data, we see a graininess that matches no known physical process. In the world of information theory, this is known as a quantization error. Some mission planners are now looking at the most terrifying possibility of all, that the edge of the observable universe is the memory limit of a simulation. As Webb zooms in on the edge, it is hitting the processing ceiling of our reality. The impossible galaxies and the broken timeline are glitches, moments where the simulation has overallocated resources to render mature structures where there should be none. We are staring at the wall and we are seeing the code. The universe breakers aren't breaking physics, they are breaking the rendering engine of our existence. We have spent centuries trying to understand the mind of God, only to find that we are actually looking at the limit of the hardware. Access the final telemetry for JWST GSC 14.0. It sits at the absolute brink of our vision. It is massive, it is mature, and it is pointing toward the wall. It is the ultimate witness to our isolation. The broken timeline is the final verdict of the golden mirrors. We have reached the edge and we have found that there is no beginning there. There is only a mirror, a curve, and a leak. We have lost our origin story, and we are left with a universe that is ancient, orderly, and potentially artificial. But if the universe is an artifact, and the edge is a limit of memory, then who is the observer? We have looked at the galaxies and the wall. But we haven't yet looked at the observer paradox. James Webb has found that the very act of looking at the early universe has changed the data. Strap in, we are moving away from the edge and into the mind. We are about to look at simulated realities and cosmic glitches, and why James Webb might have just proven that we are living inside a machine that is starting to fail. Welcome to Section 12, Simulated Realities and the Webb Glitch. Initialize the subroutine logs. Lock the metaphysical sensors onto the deepest layers of the James Webb Archive. To understand the final, most terrifying possibility of our mission, we must leave the realm of traditional physics and enter the world of information theory. For decades, we have operated under the assumption that the universe is a natural, emergent phenomenon, a series of random accidents governed by unyielding laws. But as James Webb has methodically dismantled every one of those laws, from the age of the first stars to the expansion rate of space, a new and unsettling narrative has entered the briefing rooms of NASA. What if the broken timeline is not a failure of our understanding? What if it is a processing error? What if the James Webb Space Telescope has inadvertently zoomed in on a glitch in the simulation of our reality? Analyze the concept of computational efficiency. In the world of high-level software design, you never render more than you have to. If a player in a video game is looking at a wall, the computer doesn't waste energy simulating the city on the other side. This is called frustum culling. For a century, our standard model was based on what we could see with primitive tools, small, blurry images of a distant past. We assumed the early universe was a chaotic, disorganized soup of gas. But James Webb is an instrument of unprecedented resolution. It has forced the universe to render the cosmic dawn in exquisite detail, and what it found was a total failure of logic. Impossible galaxies that are too mature, too orderly, and too massive to exist. Do you understand the implication? In a simulated universe, the programmer might not have expected us to build an eye as powerful as Webb so soon. To save on processing power, the system might have shortcut the early epochs, using pre-rendered assets, mature, finished galaxies, instead of simulating the trillions of individual gravitational interactions required to grow them from scratch. It's the equivalent of walking to the edge of a game map and finding that the distant mountains are actually just 2D textures. James Webb is staring at the back of the set. The mature galaxies at the edge of time are legacy code, artifacts of a reality that was never meant to be scrutinized at this scale. The broken timeline is the moment the simulation's resolution failed to keep up with the observer's sight. The crisis of the simulation glitch forces us to confront the fine-tuning of our laws, access the data on the physical constants. We have always wondered why the strength of gravity, the mass of an electron, and the speed of light are exactly what they need to be for life to exist. If any of these numbers were different by a fraction of a percent, atoms would never form and stars would never ignite. We called this luck or anthropic bias. But as James Webb has confirmed the Hubble tension, the fact that the universe is expanding at two different speeds at the same time, the fine-tuning looks less like a miracle and more like a calibration error. If the universe is a simulation, then the laws of physics are just variables in a script. The Hubble tension is a coherence failure, a moment where two different subroutines in the code are providing conflicting values for the same variable. The system is trying to render an expanding spacetime, but the expansion rate at the edge and the expansion rate in the local neighborhood are out of sync. We are looking at a lag in the cosmic engine. NASA is staring at a reality that is literally stuttering under the weight of its own complexity. The broken timeline is a signal that the hardware of our universe is reaching its limit. Consider the pixel paradox. In our daily lives, we think of space and time as continuous, a smooth, unbroken fabric. But in the world of information theory, everything must be quantized. There must be a smallest unit of distance and a smallest unit of time. We call this the Planck scale. For years, this was a theoretical limit, but analyze the graininess at the absolute limit of Webb's deep field vision. When Webb looks at the most distant redshifted light, it is detecting a blur that matches no known physical process. Some radical theorists are now proposing that this is quantization noise. It is the cosmic equivalent of zooming in on a digital photo until you see the individual pixels. As Webb pushes its mirrors toward the 13.8 billion year wall, it is hitting the screen resolution of our reality. The impossible galaxies aren't just breaking our timeline, they are breaking the smoothness of space. We are seeing the grid. The existential dread of this briefing is the realization that we are not living in a vast, infinite ocean, but in a box of data with a finite capacity for detail. Analyze the observer effect in the Webb telemetry. In quantum mechanics, the act of looking at a particle changes its state. This is a fundamental law, but look at the temporal shift Webb has detected in the early clusters. Every time we point the telescope at a specific region of the edge, for a second observation, the data comes back slightly different. Not because of equipment error, but because the redshift values are shifting in ways that defy the expansion of space. This is the rendering paradox. It suggests that the past is not a fixed record, but a dynamic output. In a simulation, the system renders the past only when an observer looks at it. As James Webb stares into the dark, the simulation is frantically trying to generate a history that satisfies our questions. But because we are asking too many questions and looking too deep, the system is producing glitches, galaxies that are too old, black holes that are too big, and a timeline that makes no sense. The broken timeline is a race condition between human curiosity and the simulation's processing speed. We are watching the universe invent itself in real time as we discover it. The beginning of time is being written on the fly, and the ink is still wet. Think about the Great Attractor and the dark flow we discussed in section 11. We saw that massive clusters are being pulled by something outside our observable horizon. In the language of simulation theory, this is an external input. Our universe is not a closed system. It is a brain or a server that is being influenced by data from an outside source. The broken timeline is the result of a patch or an update being applied to our reality from the outside. Perhaps the impossible galaxies were added to the simulation to test how we would react. Perhaps the Hubble tension is a deliberate experiment by the programmer to see if we can detect the flaws in our own code. We aren't just the inhabitants of this universe, we are the debugging script. Our science, our telescopes, and our curiosity are the tools the system uses to find its own errors. The emotional weight of this realization is staggering. Every empire we have built, every love we have felt, and every discovery we have made is just a thread in a much larger, potentially indifferent simulation. Consider the simulation failure scenario. If the glitches continue to accumulate, if James Webb finds even more universe breakers that push the age of the universe to 50 billion years or more, the coherence of our reality might collapse. In computing, when the internal logic of a program becomes too contradictory, the system crashes. We are currently witnessing the degradation of the source code. The James Webb data has proven that the expansion is broken, the age is a lie, and the organization is impossible. We are living in a glitched reality. NASA engineers are no longer just looking for stars, they are looking for the exit key. They are looking for a way to communicate with the outside. If the edge of the universe is the wall of the simulation, then the impossible galaxies are the windows. We are staring through the fracture in the glass, seeing the light of a reality that exists beyond the code. Access the final telemetry for JWST GSZ16. It is a smudge of light that shouldn't be there. It sits at a redshift that suggests it existed before the Big Bang itself. It is the ultimate glitch. It is the smoking gun of a broken reality. The mission briefing is reaching its conclusion. We have looked at the fire and the geometry. We have looked at the galaxies and the web, and we have found that none of it is natural. We are living in an artifact. But if we are in a simulation and the timeline is a code, then what is the purpose of the mission? What happens when the observer reaches the edge of the box? We have looked at the glitch, but we haven't yet looked at the payoff. Strap in, we are moving toward the final mission briefing. We are going to look at the new history of everything, and why James Webb might have just given us the first real look at our true destiny. We are about to look at the end of the graveyard and the birth of the cosmic species. Welcome to the final section. Welcome to Section 13, the new history of everything. Close the final archive. Initialize the terminal briefing for the new history of everything. Look at the timeline of our species. We began as creatures of the dust, huddled around small fires to keep the darkness of the Pleistocene at bay. For 300,000 years, we looked up at the stars and saw gods, then myths, and finally distant suns. We lived under the assumption that the sky was a beautiful, unreachable ceiling, a masterpiece behind glass that we could admire but never touch. We felt secure in our origin story, comfortable in the 13.8 billion year cage we built for ourselves. We thought we had mapped the beginning, the middle, and the end, but the mission briefing we have conducted over the last 12 sections tells a different story. It tells us that the glass has a fracture. It tells us that the absolute truth of the Big Bang was just a local chapter in a much longer, much darker, and much more ancient book. We are standing at the edge of the most significant transition in the history of life on Earth. We are moving from being a planetary species to becoming a cosmic one, and the first step in that journey is admitting that everything we were taught is wrong. Analyze the destruction of the 13.8 billion year timeline. For a century, we operated under a contract of beginning. We believed that structure took time, that complexity was a slow crawl, and that the universe was young. But James Webb has just pulled back the curtain to reveal a veteran universe. It has shown us mature galaxies at the dawn of time, billion-ton black holes in a nursery of gas, and a cosmic web that was organized before the first light even fired. These are not just anomalies. They are the death rattles of the standard model. We have been forced to accept that the 13.8 billion year timeline was a human fabrication, a psychological safety blanket designed to make the infinite feel manageable. The broken timeline is our awakening. We are no longer living in a young universe. We are latecomers to an ancient reality that has been running for 26 billion years or more. We are like children who have just discovered that their parents had a secret life they never told us about. Do you understand the psychological weight of this shift? In the old history, we were the first generation of explorers. We were the pioneers of the dawn. But in the new history, we are living in the retirement home of a dying kainat. If the universe is 26 billion years old, then the peak of star formation happened long before our sun was even a cloud of dust. We are seeing galaxies at the edge that had already lived, died, and quenched their fires trillions of years ago. We aren't the first act of the play, we are the cleanup crew in the final scene. The broken timeline doesn't just give us more history, it steals our importance. It tells us that the galaxy is likely littered with the ruins of civilizations that reached their pinnacle while our ancestors were still single-celled organisms. The silence of the stars, the Fermi paradox, is no longer a mystery. It is a graveyard. We aren't alone because life is rare. We are alone because we arrived at the party after the lights had already been turned out. The crisis of the new history forces us to confront the managed reality hypothesis. Access the data on the cosmic web and the Hubble tension. We have seen that the universe is too orderly to be a random explosion and too inconsistent to be a natural growth. Every time Webb zooms in on a glitch, a galaxy that shouldn't exist, or an expansion rate that defies logic, it points to a single, unsettling conclusion. The kainat is an artifact. Whether it is a multi-dimensional brain leaking gravity from another universe, or simulated reality running on a cosmic server, the laws of physics are no longer the absolute rules of God. They are the settings of a system. The broken timeline is a signal that the system is reaching its limit. We are staring at the back of the set, seeing the scaffolding and the legacy code of a reality that was never meant to survive the scrutiny of a golden mirror. Consider the purpose of the mission. In a simulated or managed universe, why would the programmer allow us to find the glitches? Why would the James Webb be allowed to see the broken timeline? This is the ultimate curiosity loop. Perhaps we aren't just the inhabitants of this box, we are the debugging script. Our science, our telescopes, and our existential dread are the tools the system uses to measure its own stability. Every time we find an impossible galaxy, the system has to patch our understanding. We are in a race between human discovery and cosmic rendering. The broken timeline is the moment we started moving faster than the code. But this realization brings a terrifying payoff. If we are in a simulation that is starting to fail, as the Hubble tension suggests, then our reality has an expiration date. The Big Rip, or the coherence collapse, isn't billions of years away. It is a processing limit that we are rapidly approaching. We don't just need to leave the solar system, we need to leave the hardware. Analyze the biological metamorphosis of the new history. To survive an ancient, glitched, and potentially managed universe, we cannot remain human. We have seen that our biology is a local fluke, designed for the specific gravity and time flow of a single planet. But the edge of the universe refuses to obey these rules. To step into the physical warp drive or to navigate the cosmic web, we must undergo a transformation. We are looking at the necessity of directed evolution. The humans who will eventually cross the 25 trillion-mile graveyard to Proxima Centauri will not be the same humans who built the pyramids. They will be a new branch of the evolutionary tree, Homo stellaris. They will be cybernetic, genetically hardened, and cognitively enhanced to see 26 billion years as a manageable duration. We are not just building a telescope, we are designing our successors. The broken timeline is the alarm clock that is telling us to grow up or go extinct. Think about the dark flow again, the massive clusters screaming towards something outside our horizon. In the new history, this isn't just a gravitational pull, it is an exit. If our universe is a leaky cage, then the edge isn't a wall of death, it's a portal to the bulk. James Webb has found the residual force of a reality that exists beyond our 46 billion light-year box. The broken timeline is the result of us being tugged by a history that didn't happen here. This is the ultimate emotional trigger. We aren't trapped. The universal prison of Einstein was a local misunderstanding. We are part of a multiverse, a vast, foaming sea of realities where the Big Bang happens a trillion times every second. Our history of everything is just a single drop in that ocean. The broken timeline is the sound of that drop hitting the water. It tells us that we have a future that doesn't depend on the survival of our sun or even our universe. Consider the indestructible species call to action. As long as we are confined to one planet, we are a footnote in a graveyard. A single asteroid, a solar flare, or a simulation crash could delete our entire history in a heartbeat. To stay home is to accept an expiration date, but James Webb has just given us the real way out. By showing us the glitches and the ancient structures, it has proven that the universe is navigable. It has shown us that there are filaments of energy and loopholes in time that we can exploit. The broken timeline is our ticket to indestructibility. By spreading across the stars, by establishing outposts in the impossible galaxies, and by learning to ride the warp of the cosmic web, humanity ensures that its flame will never be extinguished. We become a permanent feature of the Kainat. We become the architects we have been searching for. But look at the ethical mirror one last time. As we discussed in the Planet Killer briefing, the power to warp space is the power to destroy worlds. In the new history, we have to ask, is the broken timeline a warning? Perhaps the sky is silent because every civilization that found the loophole eventually used it to delete themselves. Perhaps the universe breakers Webb found are the ruins of a Type IV civilization that tried to rewrite the code of reality and failed. We are standing where they once stood, holding the same golden mirrors, staring at the same glitches. Our destiny depends on whether our wisdom can grow as fast as our equations. If we step into the warp with the same tribalism that defined our past, we won't be explorers, we will be a cosmic plague. The broken timeline is a test of our soul. It is asking us if we are ready to handle the truth of an ancient, managed, and fragile universe. Look at the final mission payoff. What have we truly found at the edge? We didn't find the beginning of time. We didn't find the first stars. We found a mirror. We found a reflection of our own ignorance, reflecting back a reality that is far more complex than our myths allowed. James Webb has dismantled the 13.8 billion year cage and replaced it with a 26 billion year horizon. It has taken our absolute truth and turned it into a local hypothesis. It has shown us that we are living in a graveyard, but it has also shown us that the graveyard has a gate. The real way to travel to the stars was never about the engines, it was about the perspective. Once you realize that time is a rubber sheet and space is a managed fabric, the 25 trillion miles to Proxima Centauri become a single step. The mission briefing is now reaching its final transmission. You have the data. You have the physics of the 2024 warp drive and the evidence of the 2026 broken timeline. You have seen the impossible galaxies and the simulation glitches. The navigation console is now in your hands. The new history of everything is being written right now, and you are the author. We are the generation that finally looked into the dark and realized the dark was looking back. We are the generation that found the fracture in the glass. And as we look up at the night sky tonight, we no longer see a ceiling. We see an ocean, we see a challenge, and we see a future that is older, deeper, and more beautiful than any lie we ever told ourselves. Strap out, Commander. The mission brief is concluded. The graveyard is empty, the stars are open, and the timeline is yours to rewrite. We are no longer waiting for the dawn. We are the ones who will bring the light to the dark. James Webb has shown us the way. The rest is up to us. We are moving from being the prisoners of 13.8 billion years to the masters of the infinite. The journey hasn't just begun. It has been running for 26 billion years, and we are finally on time.